So when you said because like I read that I just so my issue was weekends. So I just then don't get the second say that.
All right, everyone, thank you for coming right before spring break. Really, it means a lot to us. And again, my name is Young Wang. I'm one of the co-organizers for our ICON seminar together with Professor Tolle and Professor Nam Patrick Hoon, who is stuck in their ECG faculty search. And our speaker today actually has been stuck in our civil engineering faculty search a lot as well. So really appreciate your time to join us to give us this talk. Our speaker today is Professor Sogand Hasanzadeh from civil engineering and also construction management and engineering at Purdue. She gets her PhD degree from civil engineering from Virginia Tech and 2 master's degrees from civil engineering, one from University of Nebraska-Lincoln, one from her home institute in Iran. She has done a lot of research in smart construction, wearable devices, cyber physical human systems, AR, VR, XR, all this cool stuff, which she will show in this talk. And I personally also very look forward to learning from you. And with that, the floor is yours.
Thank you. Thank you so much, Ziran. I really appreciate it. Thank you for the invitation. So it's such a pleasure to be here. And so as Ziran mentioned, I'm Sogand. I'm assistant professor in civil engineering, construction engineering and management. So I'm wearing 2 hats actually. And so today I'm mainly going to talk about like one of our research direction. But before I just start talking about all those aspects, I want to just say that like all the things I will talk about, the credit was given to my students. So without them, so none of these ones were possible. And today mainly I'm going to talk about the research that Vichy, my assistant who is here, is actually doing, and what we are doing in my lab. So we named the I2 SAFE, which stands for the Intelligent, Inclusive, Safe Built Environment. So we are exploring several aspects of the technology and applied sciences in order to find engineering solution and behavioral intervention to address the issues and complexity that we are facing in the current and future workplaces. So we are looking at the like these problems from the multidisciplinary point of view. So all the research that we are doing, it's not only like civil engineering. As I start talking about it, you may wondering that, oh, like you said that you are a civil engineer, what are you doing in this aspect? So, but these problems that I'm going to talk about it, they are actually about what are the issues that we are facing in construction industry. And then we try to address the real world challenges and then try to translate our results into something that the construction industry actually can use. So, and I always consider myself as like a mentor to prepare the next generation of our workforce and the professionals. So I talk about the interdisciplinary research. So everything that we are doing in our research group is a combination of civil engineering, construction engineering, and management. It has the case of psychology, neuroscience, mechanical engineering, industrial engineering, sometimes biomedical engineering, and you would just say, what we are doing, that we need to know all of these things. So because we try to address 3 different pillars: safe, intelligent, and inclusive. So the project that I'm talking about, I'm going to explain to you, is actually cover all these 3 aspects. So the project that I'm explaining is funded by National Science Foundation under Future Work Grant. And then we have a very diverse team from the civil engineering, industrial engineering, psychology, industrial engineering, computer science, business school, and education. So which means that we are addressing all aspects, and it's a team combination of the Purdue University and George Mason. We have amazing students that they are working on the project, but mainly the work that I'm gonna today present as what my PhD student, which is doing. So this is the whole overview of the project that we are looking at. Each one of us are looking at one aspect of that one. And we have the different aims, and the most important one that we are looking at is that how the future construction job site will look like, and how we can ensure that it's the safe and inclusive place. So the current construction environment is very hazardous environment. After the agriculture, usually construction industry will be ranked very high in terms of the number of injuries and fatalities that we have in the work environment. So why? Because it's different from manufacturing setting. It's uncontrolled, dynamic, and complex. And we think that the future construction job site is gonna be less labor intensive, potentially it's less hazardous, and then we have more control over the environment because of all the robots and sensors that we put it in the place. So my question for you is that, will the workers still exist in the future construction environment?
Good question. Where do you get this photo, this picture? Is there an AI?
No. You see, I'm looking at my student. No, but I have some cool pictures actually that I asked the ChatGPT to create it for me. Yeah. So, but do you think that like workers will still exist in the future construction job site? How many of you think that it's gonna be fully automated construction job site? We have all the robots, we do the like program everything, we have the robots there that will build it for us.
Depends on it is on Earth or not.
Good point. Both.
In near future, this will be. But maybe 100 years later, it's not dying.
But if we're building in a space, do you think that we are gonna do everything?
I think for space, definitely most likely to be fully autonomous.
Mhm.
Highly autonomous. Maybe on Earth, not so much, because, you know, we've had the technology to have autonomous flight for a long time, you know, so there's going to need to be oversight to some degree, regardless of the extent, that's it.
How many of you, if you think that like there is an airplane that is just like completely autonomous and there is no pilot there, you will get on that plane?
Statistically, that's the best option. Statistically, the best human drivers would come close to a standard framework level for autonomous driver as it is right. So statistically, that's true. But the point about comparing someone driving like an aircraft versus people working on an environment is entirely different metric, because a flight, top 1% of people take a flight every day. Everyone in US does, because most people lie in the top 20% of the global community. People who do construction work are generally people who are, let's say, people who want to reduce the amount of money spent on that particular building. So unless you're building spacecraft, which you're building something in Mars, that's not happening in next 40 years. I'm going to take that back. So it's all more matter of economics. Economics will work much better, and they can work right now. Most of the pilots also do autopilot. The amount of people who do the FIA studies on what is the percentage of people who drive an autopilot, it's pretty good. So it's already happening. Technically, it is not, may or may not be happening. People can say the pilot is sitting in the chair, but he's not observing everything, because the amount of density is just so low and the probabilities are such that it works. And people will get on the flight, even if you don't tell them. People get on the flight all the time on automatic metros in Japan. There's an automatic metro in France, in Lille, which is going on since 2000. So we're doing that all the time. If there are fixed parameters and it's cost cutting, we will do that. If the cost is too high, as it is in construction, because the activities geared towards minimum cost, then autonomous scale will not go, but the scale of autonomous will.
So there are a couple of points that mentioned based on the discussion. I'm the one that I think that we are still gonna have workers. We cannot get rid of the workers. And we can, because there are a lot of uncertainty in our construction environment. Coming back to the point that he mentioned, that it's very difficult to replace workers with companies like robots. But as we were talking, there are many concepts that we talk about. So when we talk about the robotics, one, we are always behind, way behind the manufacturing setting, but robotics is not a new concept for construction people. So for years and years, as almost like 57 years, so we are using robots in the construction environment, as you see here, so that they are all like going up. But the difference is that if in the future environment, we want to have the robots, or in the current environment that we have robots, there are some concepts that will come into play. So first of all, is that the workers need to communicate with drones and will interact with artificial intelligence. And then, so then there is another concept that human should not only team up with the human should team up with autonomy. And then human, because your team member is now a robot or autonomy, you need to learn about how to trust. The question that I ask, if you will get on that plane or not, that's because of the trust and the threshold that you have. And I think that only 4 or 5 of you just said that you will get on a plane. Definitely, I'm not going to get on that plane. And the dynamic hazard. So the future environment, it's dynamic. But the other thing is that because of the auto agents. So we have the auto agents or the autonomy there that will impose extra uncertainties in our environment. So these uncertainties are mainly around trust building. How are we going to build the trust? How are we going to team up with those robots? If our workers are actually ready for that one or not. Situational awareness. So yes, the environment is already hazardous. But if you have robots around, if you have AI, you need to be situationally aware about them. Because probably if you don't take care of yourself, you can be easily struck by a drone, right? And then inclusivity. So we want to make sure that then with using this autonomy, the construction environment will be more inclusive environment for having people with the various abilities and disabilities. And then the last one is communication. Even we all have a problem to communicate with human beings. Even anyone that we meet for the first time, it takes time for us to just learn about how to communicate with it. Do we know how to communicate with robots or not? This delivery robots that we have it around. So the first time that I want to communicate with that one, I'm like my grandma that is trying to do the video call with me, right? So I'm really, and I saw that like you guys, like the students are just better in that interaction because we are from a different world. That was for me, that was the first time that I'm seeing a delivery robot. So that's why that I need to learn about how to trust the system and then how to communicate with the system. So I'm going to talk about like the very like overview about each one of this one, that how we study those. So the first one is that why even we need to study the human autonomy trust or worker autonomy trust in construction. So we look at the literature in order to understand that what are the studies being done in this area. There are a lot, hundreds, thousands of studies in the human robot trust. So we did the literature review on those ones to see that okay, so what is happening? What is the definition of the trust? So what is happening in terms of the human robot trust in the construction? And then we want to see that how the inappropriate level of trust might impact the worker's safety. So we look at the literature, and there are 2 main concepts that is missing. So first of all, most of the studies that they are out there, they are looking at the influential factors of trust, and then they are not considering construction variables. When we talk about the construction variables, it's just about the different equipment, workers, multi-equipment at the job site, the hazard at the job site, or other things, because we are talking about the environment that is more dynamic than the manufacturing setting. So we want to understand that what are the elements in construction environment and how we can benefit from this technology in the future. So I'm not going to go in deep on those ones, but very, very comprehensive literature review that we conducted. And then there are the main findings that we have is that we only have these 6 papers in the construction industry. So that there are only 6 papers that they look at, that there are 2 of them are my students, so that they all look at the human robot trust. So, but there are some of the things that they are missing. When we are looking at the factors, they are underexplored. So not all the factors that we know in the literature about human robot trust is being covered in this one. The calibration, trust calibration, I'm going to talk about it, never ever being discussed. And then the measurement, as you see, majority of them looking at the self-report trust measurement when they are looking at the human robot trust. So, but the literature is showing that there are different factors that impacting human robot trust and then better teaming. So human factors in terms of dispositional, situational, or learned factors, robotic factor that is about attribute-based or the performance-based, and then the environmental factors, the mental workload, the time pressure, mental model, or the task nature, or the complexity of the task. All of these factors can impact it, but as you see, in our literature, there is no study about these aspects. So, but I talk about the calibration. What is trust calibration? So if I'm telling you that I do not distrust my partner, do I mean that I trust him? Not necessarily. Don't take it personally, Bessa, my husband's here. So if I say that I do not distrust my husband, it doesn't mean that I trust him. So maybe I'm in the range of the untrust. So, but when we are building a trust, or we say that we trust the person, we should be very careful that, like, what is the level of our trust? Calibrated trust is the appropriate level of trust, but we may go to the over trust or under trust. That is the same thing for the human robot trust. There are 2 points is that when we talk about the trust is not a static measurement. So it's a dynamic one. It will be updated based on the situation that we are exposed. And then we need, there are some effective strategy to manipulate the level of trust, and we should just do it to see that how it will impact workers. In terms of the trust measurement, there are several studies being done. They are using the self-report. It has the pros and cons, all of this one. It's easy to use, but it's not real time, it's biased. The behavioral, it's real time, but we cannot generalize it. The psychophysiological data or responses, it's real time, but one-to-many correlation, right? We should make sure that how we can use the combination of these factors or these different measurements in order to have the real-time monitoring of the worker trust on automation. So as we see, there are many gaps that we were able to identify, and that helped us to come up with the different level of the worker-robot trust. So the first level is the static one. We are the standalone, like that worker-robot construction job site. We think that, like, they're gonna build a trust, and the trust that we are looking at here is not dynamic, it's static, that most of the literature will look at. Dynamic trust, which means that, like, that as you see, it's getting closer to this part, which means that based on the interaction of these elements, the trust level will be updated, and we should have the real-time measurement of the trust. And the last one is adaptive, so which means that, like, the trust should be calibrated. Many things may happen at the job site that we lose that trust on the system, and then we should be able to bring it back to the calibrated one. So we learned all of this one from the literature. We identify what we should study. And the next level is that, okay, let's see that if there is something happening and we are impacting the trust of the workers in autonomous agents, then how it's going to impact their perception, their trust level, how it's going to impact their safety performance. In this study, we know that no like autonomous agents have the perfect performance. Definitely there is some like fault, and all of us will see it in our day-to-day life. And then we see that, like, that if we are using any system, probably you see this delivery robot that I talk about many times, that you will find it that is just confused, don't know where to go. So none of the robots, none of the system like auto agents that we have are just perfect. The same thing for construction environment. Those robots that we have, they are not perfect. And then, which means that they might fail to some degree. So, which means that they may not have their expected performance. thought about this, so it's not good. Okay, so but the problem is that if there's something happen or our system is failing, who's gonna take the responsibility? Is it gonna be the worker or they gonna blame the robot based on the like failure that is happening? And then the other factor is that if one robot or one system at the job site is just failing, how it's gonna impact the other auto agents or the trust on other auto agents. So for example, if I'm trusting this delivery robot on campus, if I get on Yihings or Xeron's autonomous vehicle, can I trust that one to the same degree or not? So in order to do that, so we look at these two concepts. First of all, who will accept the responsibility of the failure, and then how the trust will transfer from one agent to another agent in the construction industry. So for doing that one, my team developed a future construction environment where the workers need to build a wall while they are interacting with Mule. Mule is this one, as you can see it here. It's actually the accepted system and actually being used, the commonly used brake lane system that we have in the construction industry. And then this is semi-autonomous robot. It has a, like, the only thing is that like you will grab the red box that you see here, and it will help the workers to pick up the blocks. And then they don't feel any weight, actually. So, and they will place it there. So it's a semi-autonomous robot. It's not the autonomous robot here. And then there are different drones at the job site. And then we expect that in future, the drones will do the inspection, will deliver the materials when it's needed. And then they also will provide some information in terms of like, the design change. And now you need to build the wall in different way. So for example, as you see, they are putting the blocks horizontally. And then they suddenly, the robot will come and then using like will augment it and say that the design change, and now you need to put the walls and the blocks 45 degrees, right? And then it will help the worker to understand that what changed, and then they need to actually build the wall. There is also AI assistant that we have there that we just saying like what drone is getting close to you, what is that drone, what is gonna deliver to you, or what message it has for you. So why? Because there are many robots, it's just going on. And then the participant also not only just be in the environment and doing the task, they also wearing different trackers to synchronize their body movement with the avatar. They are wearing the medical wristband that we are looking at their physiological responses. They are wearing a Peniers cap that is the portable version of fMRI. So we are looking at the oxygen level of the brain, and then we see that which part of the brain are more activated, and there are eye tracking sensors embedded into the headset. So we know what they are looking at, how they are looking at, if they are paying attention to some points or not. And in between, there are also some survey that they will fill out. So as you see, there are 3 levels of the like measurement for us. So they complete the task, which is building the wall under the baseline module. That means that like nothing is happening, everything is perfect, robot is having the perfect performance. And then the error module. And one thing I should say, in my team, whenever we are simulating something, because we want the main expertise that we have is about the smart safety, we are not that nice, actually. So for example, if we say that it's the error module, we actually want our participant to experience if the system has not perfect performance, then what will happen? So what questions we were asking about in this trust survey? We are asking about like that their trust level on the auto agent right before they start the module, which is the baseline that we are looking at. After they are done with the baseline module, everything went perfect, right? And then error module, they will do it. And then after that one, we will ask about the trust and talk about like the subjective measurement. So there are different failures that we simulated in the environment. So the mule will fail in a way that is not working properly. So when they grab the block and they want to put it there, it's either not going to grab their block, or when they want to leave it, it's not going to work when they click on the button. The drone will fail. We are not nice. As I said, we hit the other workers with drone. unfortunately, the person will die, and you're gonna hear the sound that what happened to the person. And then the other thing, we hit the participant with the drone if they are not situationally aware. So why we are not nicely simulating it, but we are not doing it in real world, right? But after that one, they will just say, oh my God, what happened? Because they see the drone will come to them. And then the area assistant also will fail sometimes. It will provide inaccurate information. And then we want to see that how they will take the responsibility. If the system is failing, they think that if it's their problem, if they blame themselves or they blame robots that happen. So first, not looking at who will take the responsibility, we see that like if the trust actually changed before failure and after failure, and there was no significant difference between this one. So we understood that, okay, so we are looking at the different failure. So we should see that in which one of them they take the responsibility, in which one of them they do not take responsibility. So dividing the participants into the two categories, those that they will blame themselves and those that they will blame robot. And now we see the significant difference between them. So those, and we see that like attributing responsibility actually significantly impact their trust. Those ones that they blame robot, their trust reduced more. That's why that is negative. And then we want to see that like, okay, now if one system, for example, they identify the error in the mule system, if they actually will impact their trust on the drones or not. So the multi-robot trust transfer that I mentioned, if one system is failing, if it's gonna impact the other system or not. And we saw the significant difference, right? Those that they will, we can see that those that they identify an error in one of the systems, they reduce their trust on the other system more significantly. So we are talking about two concepts here. So one of them is the overtrust on the system. And then the other one is the inappropriate trust transfer, that if there's one system is having a problem, it's also impact the trust of the other system. So this is going to be the huge safety issues. Construction environments, we already have a problem with the safety, and it seems that having the robots there, and if they are not working perfectly, we're also going to have the enhanced safety issues. The other aspect that we look at it is situational awareness. So just imagine that like now we are sitting here, but they're all like drones just going by here, just tracking everything. One of them is, I don't know, taking care of like cleaning. The other one is taking care of another thing. So one thing is that you guys just pay attention to me. The other thing is that you want to also, you pay attention at the same time, you make sure that you are not going to be struck by that drone. That's the same thing that we want to simulate. So we want to see that like that how they allocate their attention to the dynamic objects. So robots going by, and then also the drones around, while they actually need to do a task. And we want to see that like that how the time pressure will impact their trust. Time pressure is not something that we need to impose to construction industry. It's already there. They always will ask to do the task faster, and they will always there is a productivity demand, do more and more. So time pressure is the integral feature of the construction environment. So, which means that it's kind of like a balance, like trusting the system, catching up with the time pressure, or just paying attention to the system around, and that's okay if I miss the deadline or the milestone that we have. So we want to see that how actually, which one is actually have the dominating role, the trust or the time pressure. So we look at the different measures here, that one of them is that our area of interest are the dynamic drones that they will go around. And then the situational awareness is that the amount of time that they dwell, fixate on that specific drone as it's going by. The other one is run count. Run count means that how many times they bring their attention back. I'm working, I check on the drone, I come back, I check back on the drone. This is one run count. And then this is exactly like the timeline that I told you. So the trust survey, and then we have the baseline, then another trust error, another trust measurement, and then we have time pressure. time pressure, how was it? Is that we give them a specific time, and then more blocks, every block that they install, they're gonna get like $10 extra. So we are actually simulating what they will experience in the construction environment. And then there are several factors, baseline versus the time pressure factor, and then those that they reduce their trust versus those that they didn't reduce their trust after the error module. So we need to look at these two together. That's why that we conducted the mixed design ANOVA to see that whether the trust change is impacting their situational awareness or it's a time pressure that is impacting their situational awareness. Here you see that is the first level, like a baseline trust after the baseline, after the error, and then the time pressure. What you see is that the trust at the beginning was some like 3.5. It went up after the baseline module because everything worked perfectly. And then it dropped suddenly because of the error module. And then under time pressure, they prefer again to go back and increase their trust. Why? They already saw that the system is not perfect. So in total, 72% of the participants reduced their trust, 28% of them, they didn't reduce their trust, and we want to see the difference between these two. So the orange one is showing those ones that they reduced their trust on the system, and then the gray one is showing the one that is actually, they didn't change or retain their trust level. So one thing that we see is that decreasing trust is not significantly impacting their situational awareness. And what is impacting is the difference between the baseline and the time pressure. So time pressure is actually playing a dominating role in worker situational awareness, not the trust one. So what does it mean? It means that when they are under time pressure, even if the system was not perfect, they prefer to trust the system. So when the person is under time pressure, they might experience attention autonomy. Because first of all, your time pressure, you're under time pressure, the working memory load on you is higher. So which means that the attentional capacity that you have will be more limited. So they will go to the overtrust. You remember, like I showed you that there is calibrated trust. This is a perfect one. Under trust and overtrust are not good. Overtrust is very bad, because they were start not looking at the robots and drones, and they are mainly focusing on the brake lane tasks that they do because they want to get more money, actually. So, and the last one that I'm going to talk about, part of our project is that people, regardless of their ability and disabilities, should be welcome to the future construction environment. One of the groups that we are focusing on are the workers with ADHD, or the neurodiverse workers. Currently, in the construction environment, if the employer knows that the person has ADHD, they prefer to not put them at the job site. They prefer to put them in the office. Why? Because of the limitations that the neurodiverse workers have. But what is ADHD? So, or what is neurodiversity? So the neurodiversity argue that we might looking at the word from different angle or different view. There is no one right way to just looking at that one. There are differences, and all of them are normal. So there are a wide range of neurodiversity, from autism to ADHD and many others. Okay? We are focusing on ADHD because they have a strength that we can benefit a lot in the construction industry. They have some limitation that we are trying to address. When we talk about ADHD, probably you know that like ADHD as standing for the attentional deficiency and impulsiveness. So the ADHD individuals, they are very creative, more than neurotypical people. They are energized, they are hyper-focused, they are doing something, they are fully focused on that one. That is now we are going to the limitation. They are inattentive, they are impulsive, and then they are hyperactive. Being hyperactive is not bad if you are working in the construction environment. This is positive things. So, but impulsiveness and inattentiveness is something, because of the dynamic and complex environment, we need to focus on those things. So there is no discussion about that, like how the neurodiversity will be taken care of in construction environment. What we know is that they prefer to not disclose it to the employer. And then the construction is inappropriate for ADHD workers because it actually, it's a physical work. And ADHD individuals, they prefer to do the physical work instead of sitting in the office in front of the computer. And then we believe that the autonomy can help and compensate the limitation. But how? This is what we are trying to address in our study. But first, we should learn about like that how the ADHD workers actually will team up with autonomy. Because we saw that neurotypical people, they all still we are having some issues with those, like building the team and trusting. But how the ADHD worker can build a trust and can build a team and actually can have the help or bi-directional relation with the autonomous agent that will help them and will address their limitation. So in order to do that, we are focusing on the two aspects of their behavior, situational awareness and their productivity. So why? Because we do believe that we have the different area of interest. Some of them are about the bricklaying area of interest. Some of them are safety related area of interest. There are the drones and robots around that they are actually source of risk for them. And there are other environments that they are not hazardous. So it's important that how they will distribute their attention to identify those safety related area of interest. And then the number of blocks that they finish, it's a factor for their productivity. So in this one, we have a great help from the psychological science department. And one of our team members, Sarah, is actually expert in ADHD. Psychologist is expert in ADHD. So what we're doing is that we recruit the participants. Participants will go there and do the test. They will go through a very intense process of like seeing that if they are ADHD or not. And ADHD has a spectrum in the spectrum where they are actually. That is interesting that there are many people, they have no idea that they are ADHD. And during our experiment, they understood that they have ADHD. So there are many specific tests that they are doing. I'm not expert on that area, but what happened at the end, this result is we now have more, but when we are actually submitting this paper, we were identifying 19 subjects with ADHD. When we talk about 19 people with ADHD, that they are the real ADHD, it's not like they are in the middle. They are actually more than the average. They are the ones that they probably need help, and they are the ones that they struggle with ADHD through their life a lot. And then 68 people that they are in a lower rate of that one, and we took care of everything because depression is different than ADHD. Procrastination is different than ADHD. So all of those ones were measured there. And then if we look at the ADHD versus non-ADHD or neurodiverse people versus the neurotypical people, we'll see that those that they are ADHD, they spend 66% of their attention to the AOIs, the specific AOIs that they are about bricklaying or the safety related one. They are not that different from the neurotypical people, right? We see that ADHD people were not distracted with the non-area of interest elements in the environment. That's a good thing. But when we just try to see that in that 66%, what percentage of their attention were allocated to bricklaying, the task that they are doing, and what percentage were allocated to the safety related area of interest, which is actually the AOI, the drones, and then other robots around. So we saw the significant difference. So the ADHD individual actually focus more, most of the times, to the bricklaying task. So they are focusing on the tasks that they are doing. And actually it's one of the signs of ADHD, that they are hyper-focused. The task that they are doing, they are focusing on that one. So they are paying less attention to the drones. But then we just said, okay, that's fine. They didn't have the situational awareness. They didn't look at the safety related AOIs, but they spent more time and more attention on the bricklaying area of interest. But how was their productivity? Were they able to actually install more blocks or not? No. So they were not able to insert or install more blocks than the neurotypical people. What we understand here is that ADHD workers, while they are gonna have more focus on the tasks that they are doing, they are hyper focused, they are not necessarily gonna be more productive. And the reason for that is that they are experiencing mind wandering. So when they are doing the tasks, they are hyper focused on that task, but not 100%. And then part of that one is mind wandering that will impact their productivity. Oops. What happened? It just decided that it's time to wrap it up. So I have two more slides. Okay, let's see. Okay, so we talk about that, okay, trust building. We might have an issue in the construction and we understood that, yes, we have too much trust or we have completely distrust. So, and we need to take care of that one. We need to make sure that our workers are ready for what we are changing in our construction industry. That is not the case now. What all the construction companies are now doing is that they are super excited about this spot robot. Especially, you might saw that one, the Boston Dynamics that you see it all over the LinkedIn. So they will buy that one, they will start working on that one on the construction job site, and workers hate those spot robots because they think that they are being watched with those robots, right? And which means that like in construction industry, sometimes we are so excited about technology, but we don't look at the workers as the main ones at the job site that they need to team up with those robots. And in this one, we saw that we have trust issue. Situational awareness is a huge problem that now we are facing for the workers, and inclusivity. We see a lot of potential into just using these technology, because if these systems understand now that it's what in the next stage we are doing is the system understand the person is not attentive to them, they can provide feedback. So actually we can have more inclusive environment. So then we are just thinking about that. This is the sign that we need to move to the industry 5.0. And we call for more human-centric, sustainable, and the resilient worker autonomy teaming. I would be happy to come back next year and then explain to you like how we are developing that bi-directional relation. And so everything that I presented, I said like special thanks to my students, graduate and undergraduate students, especially Vichy, that help a lot with this project. And then a special thanks to all the other co-PIs and the students on the team. Thank you.
Thank you very much.
Very on time, right?
Very on time, very good presentation skill. And besides that, what a nicely put together slide deck, right?
Credits will give to the
right?
Vichy who will create the slides.
I don't have this HDAD or I don't know, but I have a little bit OCD, to be honest. I feel very satisfied just reading your slide deck. All these different modules that are well aligned to each other, all those edges. I pay attention to all those. So you must be, paying a lot of time building the slide deck. Now we open the floor to questions from the audience. Go ahead.
Yeah. So a big part of research has human to robot term, also robot. So it's going to be a bi-directional concept. Do you think that there is, or I guess, does your lab sort of realize that the power that they have right now with the metrics that they've generated for human intensivity and stuff, is there a plan to translate that directly into trust metric for the robots trusting the human? As you said, Street 5.0 is centric, so the robots also will need to figure out if they're not paying attention, and trust them overall, and how does that affect my own actions with this human compared to this other? Is that like the next plans for that?
Yeah, so that's a great point, because usually there were like, when they were, all the, like, most of the studies are looking at is that how the human will interact with robots. So not how the robot will develop a good understanding of who they are interacting with, right? And that's a great question, and with this research, like the next step is actually what we're gonna looking at, is that the robot should understand who they are interacting with. And then because they can help with like addressing the limitations or any way that we need help. So that's why then like now like a lot of like robots that they are being designed for the like people with different disabilities, they are actually they are trying to train them to understand that, for example, for autism. There are many different robots that are available so that they are actually understand the need of the kid and then try to respond to that one. So, but we don't have such a thing in construction. And what we are looking into is exactly what you mentioned. So to see that like how we can, based on if the person is attentive, if the person is stressed. So because we are looking at here, I didn't provide a lot of details. I mainly talk about the trust, but we are looking at the like the engineer's data, we are looking at the emotional responses and everything. So if we know that the system, the person is stressed, so then maybe the drone that is now getting close to them to deliver the material. So if they understand that the person is already stressed, they will go back, right? So instead of like, because we have like in our delivery robot, actually, it's getting too close to the person, right? And then if you are in this, if you want to try it, we can ask Richie to give you like a demo of this one, but we add the same speed for the blades that is actually for the like the robots, and also the sound. So you will see that the drone is over here, but still you want to, because you run out of mortar, so it will bring you a new bucket of mortar. So you need to grab that one and then return this one. So, and then that time they cannot reach, right? They need to ask the drone to come closer. And as it gets close, it's actually gonna be here. And we see that like suddenly their emotional responses will go up. So, but they need to do that task because they were asked to, actually. But if the robot understands that the human is stressed, maybe it can do it differently. We can have a function that just go around and leave the bucket there, and the person don't need to actually remove that one. So that is what we are looking into as the future steps of the proposal, because it's actually one of the things that we mentioned is the bi-directional. So far, we went to one direction, but we need to also make sure that the robots, because robots can understand, robots can help, and we can benefit from them, but we need to train them.
I have a question about the target for the population that you tested the study on. So were they actual construction workers or were they college students or?
So we tested like people that they have construction experience. So it can be any students, because we are looking at the next generation of workers. Right, we are in this data collection, we didn't focus on the current workforce. We are looking at the next generation of workforce. So that's why all the participants should have construction experience. Which means that they already did a construction work. They know what is that environment. So, but we are still collecting data, and then we are going to the next stage for the actually bringing workers now, the current workers, that they are less familiar even with the technology, and then see that how they will respond to it. Richie, can you tell us about how many total that we have?
So now we have 1.5.
Thank you. You're a professor, you should ask your students sometimes about the updated data.
Okay, thank you.
Yeah, awesome. Yes.
Yeah, so I'll just trying to couple those into two subquestions. And first of all, what's our objective to formally trust? Once we have that, is it target to maximize the health system, or is to and something that they actually always is to is overtrust an issue for us? Do you want to prevent workers overtrusting the system to, cause maybe neglect of mistakes, something like that? And my two questions is like, first, what's overall of the phone infection, how much overall overtrust? And second thing is like, is overtrust an issue for the system?
So, for, formulating a trust, we are actually looking at the different, variables. So there's one part of the research that we didn't present because it's a paper on the review that is actually how the physiological responses, can help to identify, the trust level or model the trust level. So which means that in real time, we can say that if this worker is actually trusting, let's say, what we look at it is not like that if the person is trusting or not trusting, if it's the trust increase or decrease, right? Because the trust is dynamic, right? Every time we should know that, like, compared to the, like, a couple of minutes ago, couple of seconds ago, if we are increasing our trust or reducing our trust. So for modeling the trust, we look at the subjective and objective data to identify that one in real time. And then why the overtrust is the issue? It is because if they are overtrusting it, it's gonna be what happened, that they're gonna have lower situational awareness. Overtrusting the system, if the system is actually not exposing a huge risk to the workers, it should be fine. But now we are talking about the dynamic environment, and we saw it, those ones that they actually overtrust the system and didn't check on the robot, the drone, they actually they experience more struck by drones compared to those that they actually pay attention. Because if you see the drone is coming, you can go, right? You can save yourself. But overtrust in construction is gonna be a huge issue, while actually most of the people now focusing on undertrust. They try to ensure the workers that everything will be fine and they should trust this technology. So while everyone focusing on undertrust, we understood that there's gonna be a problem with overtrust. And the problem is that it's direct relation with the low situational awareness. So we actually, like, the main things in the, like, the trust for us is coming back to the safety. So because the putting these things is just imposing extra uncertainties, and then that is gonna have huge impact on the safety. So overtrust and undertrust, both of them are gonna have impact on safety. That's why we are actually care a lot about it. And always overtrusting the technology is not good, right? So if you have overtrust the braking system in your car and you drive, that we usually do it, like ABS, we have it in the car. And then if you overtrust that one, drive with almost like 85 miles per hour to Indy, very close to the car which is in front of us. And all the time we think that we push the brake, we can stop. So don't try it, but if you push the brake, you cannot stop. So there is always like you should keep some specific distance. So that's why that they put those sensors now in the car, that if you going with some specific speed and you get closer, the proximity sensors that they have, the car by itself will reduce your speed, because the system already know that you are overtrusting the ABS in the system.
Any other question? Okay, I'll take the advantage to ask a question, because we're essentially working on the same problem, but I'm addressing that in autonomous driving or addressing that in manufacturing or construction. So the question I have is, it seems like a lot of the research and a lot of the results that you showed by a student is more like subjective survey, right? What are the objective measurements that you use in evaluating their trust, and also how do you avoid that those participants have bias in such kind of test, right? Because if I'm a conservative worker, even though I trust this in the animation, in the game engine simulation, I will mark myself as I don't trust it because I don't want to adopt this technology. How do you avoid that kind of biased perception? And what are the metrics, like objective metrics?
Yeah, you're right. We didn't show the results of the psychophysiological responses that we are looking at, as I said, because the paper is under review and we are recording that one, so that's why that we just, we are waiting for the papers, and then, but we are not only focusing on the subjective report. So because as you said, it's a biased one, and we mentioned, so we are using the combination one. So we are looking at like that if their emotional responses is changing. And then we are also looking at the likelihood of even like when they report the subjective risk or subjective trust that they have to the system, we always ask question about the likelihood of experiencing an incident and the consequence of that one. So we want to know about it, like that, how they perceive the risk of like being exposed to any of these robots. So we are looking at their heart rate variability changes. Actually, we are looking at their eye tracking that you see that is paying attention to some specific point. And then one of the paper that we already have it like under review, and then it's about like that we are using brain signals in order to predict the trust. So because they are more real time and they are less biased. So, and then the CNN model that we developed is, as I said, it's just putting the FNERs, EDR, which is the phasic system for the electrothermal, and then the heart rate, and it also look at the eye tracking and the subjective one together. So because, as I said, like in our review, we understood that if we have a combination of this one, we have a better prediction of the trust. In all of these papers, even we reported those like psychophysiological responses as well, but here based on the limited time, I didn't present those ones. But you are right. Subjective measurement is not gonna be enough, and then definitely we need to look at the objective data, because the people, sometimes they are reversed. They want to show that they are very cool and they are open to everything, while they are not. Sometimes they are like want to show that they are very conservative and they don't want to adopt any technology. So in order to do that one, so we have we are using all of these data together.
Great. Yeah, let's thank our speaker for the very. Great, thank you.
Yeah, the last presentation before spring break.
Yeah.